Hey, good morning, everyone. Good
Good
morning.
morning, Professor.
Hey, good morning. How are you? I see
Morning.
I see six people here, but somehow there's nobody in the there was nobody in the what's that called? Today's discussion board. So if you forgot to sign in to today's discussion board, please do it.
I already have.
Okay, okay. So let me share my screen. And let me quickly check. Okay, now it's showing. Now it's showing. Okay, good. Now it's showing. So I have seven people in the discussion board and seven in the, yeah, so the numbers are matching. All righty. So one, I have a good news and a bad news. Good news is I finally got my computer fixed. And then the bad news is I lost all my data. There was no basically the data that was already previously on my regular computer was all fried up. So basically the hard disk was completely empty. So but most of the recent files that I was using, I saved it on my external drive. So I was able to save some of that. But some of the data I need are lost. And most of them are backed up in the cloud, but the most recent files were lost. And also, since this is the new one now, so everything is now it's running on, even now it's running on Windows 11. I mean, it was running on Windows 10. And while I was using my old computer, it was running on Windows 7. So now I've got a new operating system. So everything is, I'm still, this is almost
You're
like
pretty much new to it.
yeah, it's almost like having a new computer. Um, so I don't have Microsoft Office apps installed yet. So that's the so I had to use Microsoft programs online. This is online has many limitations. Online apps have very many limitations. This is also PDF should open, but somehow I don't know why it doesn't open. So I had to open it also online. There's a lot of a lot of limitations because I have to upload all those files to OneDrive, and I had to open it from OneDrive. That is crazy. And I have many login credentials, so I have without without me knowing, without my knowledge, I have at least like 2 to 3 OneDrive accounts, and I don't know. I mean, I knew I had at least one account, but that's not what I can access. And everything I backed up in that OneDrive, I can't access through Microsoft Office. Um, so this is a chaos, still a chaos. And I don't have my, where is my, I don't have my, oh, okay. I don't have even my picture because this is new. Let me upload my, again, I don't have picture to upload currently. I'll have to do this later because I have to download it from my cloud and so anyway, that doesn't keep us from yeah, that doesn't keep us from going forward. So let me I don't know why Okay. So let's go back to our. So we were talking about the present value of annuity example, and as the second example, I believe we talked about the lottery. The lottery is not very realistic. You don't win lottery, like it's something that can happen just once in a lifetime. It cannot even, happen, for some people, it will never happen. So why do we talk about lottery example? Lottery example is pedagogically easy, because it would be a perfect example of present value of annuities. But in reality, rather than lottery, let's say you get injury settlement. I mean, you get, you have a, suppose you got injured at work, or you got injured in an accident, car accident. And then usually, if you are the victim, right, of that injury, there will be a court settlement, and the court, usually, you will get paid by the insurer of the party at fault. And if you got injured at work, probably your employer, the insurance company of the employer will pay. If you got into a car accident and the party at fault, the insurer of the party at fault will pay, damages. But this will be like annuities. I mean, the settlement, what they call generally settlement payment, it's in a broad sense. It's in a broader sense. It's a kind of annuity. Now, they call it structured settlement. Structured meaning, you get paid, at this point. You get paid at this point. I mean, it doesn't have to be annuity. But sometimes it could be, they will pay you this amount in the first 6 months, and then pay you this amount in the second 6 months, and so on. But it could also be annuity. I mean, for the next 5 years, you'll get, $2,000 every month, right? Something like that. But then, if you just receive that, there won't be a problem. But then, every, I don't know if they do that anymore, but, in the past, even in the 1990s, or early 2000s, if you're watching TV late at night, then there would be this, commercial. Were you hurt? Were you injured? We can help you. Injury lawyers, right? Somebody and somebody, right? Simon and Garfunkel. Of course, Simon and Garfunkel is not, they are not lawyers, but the law firms generally named like that. So, has anybody seen that commercial at night? Has anybody seen that kind of commercial at night? No?
Like a Celino and Bonds commercial, or?
Well, it doesn't. I don't know. I mean, who is the? I don't know the name of the lawyers, but just that kind of commercial. You must have seen that, right?
Right.
You got injured, right? And most of the times, the lawyers are basically, we will sue you for your injury, and we will help you get the maximum compensation. That's the idea. But then that's not only that. After that, you have structured settlement. You want structured settlement is usually like a piecemeal. You get a little at this time. You get a little. Let's say if you got injured and you're getting $2,000 every month for the next 3 years, and $2,000 every month is some people are okay with that, but some people get a little greedy. So and they are not really seriously injured. It's just a legal system that sues the insurance company. So you can move around freely, and so you can't, you're not satisfied with getting $2,000 a month. So what do? You want a lump sum. If there is a way you can, instead of collecting monthly, if you can get a big lump sum, you would like to get that big lump sum. And then these commercials, you see these commercials. You have structured settlement. You had an injury. You had structured settlement. Structured settlement means something like annuities. We can help you get a big check. We can help you get a big check. What does that mean? They will pay you a big lump sum payment for your annuities. You understand, right? You understand what that means? So in other words, they are going to buy your annuities and pay you. They're going to buy you your annuities and pay you a one-time check, a lump sum check. Of course, the lump sum check would look much larger than this, monthly payments. But think about it. The idea behind it is there is no reason they would pay you a lump sum check that is equal to or greater than the present value of those annuities. You understand? Does it make sense? If they are paying you, so if you're getting $2,000 annuities every month for the next 3 years, what should be the present value of that? You cannot. Usually, the people who are injured and wanting to have this big lump sum are the people who can't calculate the present value, or the people who don't have any idea of what a present value is. So they can't calculate it, but that the company can calculate it. They will, and there is no reason they will offer you a large lump sum that is greater than the present value of those annuities. They will offer you something that is less than the present value of those annuities, but to you it will still look like a big, it's a big lump sum check. Some people just succumb to that, right? And then they will take those annuities from you, and which is greater in the present value. Okay, so this is the if you think about it, that is exactly the how you calculate it is exactly like the lottery example, right? Now the next thing is, we were in our last class, we were talking about this car financing example. You're buying a $30,000 car, let me use, so one good thing is I have my, where is that thing? I have my whiteboard back, but then, this is still incomplete. This is still incomplete because So price of the car, 30K, right? And you, as I said, you need to make a down payment, and the down payment, 6K. Everyone can see the whiteboard, right? Do you all see the whiteboard?
Yes,
Yes, we
Professor.
can.
Okay, great, great. This is what I've been missing so much all this time. That's at. It's hard to write at. And then if you make a down payment, that means, loan, the balance. Yeah. The balance is the loan. Again, you don't have to arrange for the loan yourself. The dealership takes care of that. Dealership matches you with dealers. The dealership finds the dealership basically, has affiliation with the. I mean, all the most of the big automakers have their own financing arm, right? So they lend money to the buyers of their car. So General Motors used to have what was that called? GM Financial, or Chrysler has Chrysler Financial. Hyundai has Hyundai Motors Finance company, and Kia has its own, also Kia Financial. All of the automakers have their own bank, right? So the dealership basically, arranges everything for you. So you will. So $24,000 will be the loan. You make $6,000 down payment, and then so the car is paid for. Then you drive out of it. But when you drive out of it, at the dealership they said, your monthly payment was 500. 500 at 560. And your question is, what is that the correct payment? If it is, assuming that it is the correct payment, if it is the correct payment, and I said last time that there are two ways. There are two ways you can go about it. One, you want to find out if the present value of all those annuities, in other words, these $500, sum of, right, all those annuities are greater than or equal to or less than your principal. And we know our principal is 24K. So if the sum of the present values of all those annuities are greater than the principal that you owe, 24K, excuse me, then you're paying more than what you owe. And if it is equal to the principal, then that's correct. If the sum of all these present values are less than the principal, then you are paying less than what you owe, right? Now, how can that be possible? No, it can happen, but originally when they what am I? If the APR, let's say 6%, if APR is 6%, of course we know time is 5 years, and since it is monthly, periodic rate is 0.5%, and N will be 60, right? So at the time, at the original, at the time they, at time 0, when they calculated this, it is supposed to be, it should be using this 6% as the discount rate. Of course, 0.5% must be the discount rate. 0.5% must be the discount rate because we are on monthly. Using 0.5% as the discount rate, it will always have to be equal, right? If that was the, it will always have to be equal. If they used, the present values of all those annuities must be equal to the principal. That's just, it's present value. When they find the payment, right? They found the payment based on annuity payment based on the principal, right? So it has to be equal. The present value of all those annuities must be equal to the principal. But if they, unless they deliberately cheated, or unless there was an error in their program, it has to be equal. So one thing, whether this is the correct payment or not, as I said, there are ways we can verify that. One is find if the present value of annuities are equal to payment, the principal, right? The present value of all those payments, right, are equal to the principal. Or second, we can solve for the payment. We can directly, where is this thing? This is a okay, now it's better. So Oops, what is it? Why isn't it working? What happened to my other pens? Oh, I see. Okay. So, second way to do it is, yeah, we can directly nail payment. And I said, we did, both last time. I mean, I showed you how to find this payment formula last time. So this time, let's do that on Excel. So once again, you need to open this file, okay? And here we have row 16. If you go to row 16, this is basically, finding the present value of all these annuity payments, right? So if this comes out as 24K, it's the payment is correct. If this comes out as greater than 24K, then you are paying more than what you owe, right? That's really the time you have to call your lawyer, right? Because you're being ripped off. But let's see. So we already know that periodic rate is this, N is this, and using the present value of annuity formula, right? My keyboard is obviously okay. Payment over R, right? Minus payment over parenthesis R times open parenthesis 1 plus R is to N, or is it enter? I guess I'll just hit enter from the keyboard. What happened? Oh, I didn't close parentheses. I'm sorry. Here you go. Okay, so then this is the present value of all those annuities. So what can you say? The conclusion is clear. This is more than 24K, so you are paying more than what you owe. Okay, so here's the thing. Originally, right? Originally, if APR was higher, when you took out the loan, right? When you bought the car originally, right? When you bought the car at time 0, if the APR was higher, something like 8%. Let's change this to 8%, right? If it was higher, see, it's closer to present value of annuities. If it was, let's say 8.5%, try 8.5. It's showing 9, but we all know it's because it's not showing 2 decimal places. Or even if it was, 9%, if it was 9%, let's try. Yeah, if maybe, there can be two interpretations to this. One, at time zero, when you bought the car, right, the interest rate was very high. And then, it is, if it was 9%, yeah, at the time, $500 could have been the right amount. But over time, as time goes, as time passes, interest rate has changed. So now you are using, 6% currently. And then it looks like you are paying more than what you owe. But again, if this is at time zero, as I said, you are driving out of the dealership. You're driving your new car. You're driving in your new car out of the dealership, right? And at the dealership, they said $500 is your monthly payment. And if this is the bill that's going to keep coming for the next 60 months, this is clearly wrong, right? Because they are, the correct payment should be lower than this, because you are already ruined. You are set to pay more than what you really owe, right? Does that make sense? So if this is the case, of course, very good reason to call your lawyer, right? And probably you'll get a, of course, but that won't happen. That's not going to happen. In reality, they hardly make such a, mistake. I mean, if it is not a deliberate thing, they will hardly make, such an error. Okay. So the next thing is then we can nail the payment. We can nail the payment. Okay. We can nail the exact payment. So how? So here's how. And I showed you how to derive, how to solve this equation for payment. Last time, you go back to the video recording of the last session, and you will. So if you solve this equation for payment, then it's like this. Oh, come on! I get so many. So applying this formula, right? So we're going to apply that formula. Then it's PVA, so I'm going to times R times 1 plus R to the n, R times 1 plus R raised to n. The whole thing divided by now 1 plus 1 plus R raised to n minus 1, close parenthesis, and hit enter. Okay, you can put this in, right? There you go. This is the correct payment. Okay, this is the correct payment. So that proves, that's the way to prove. There are two ways to prove that you're being ripped off. One, find the present value of all these annuities, and if it is greater than the principal that you owe, then you're overpaying. Second, you find the exact payment based on the original principal, because if this is the correct payment, present value of all these annuity payments be equal to the principal, right? And then solve for payment, and you get. So with these two evidences, you can now sue the dealership, right? Or the bank or the dealership. But anyway, so this brings us to the next question, which is called amortization. Now, so remember, we have covered future value of annuities and how to solve for the payment in the future value of annuities, right? How to solve for future value of annuities, annuity due, of course. How to solve for present payment in future value of annuities, and also how to solve for present value of annuities, and how to solve that for payment, and also how to solve for N in the future value of annuity, and how to solve for N in present value of annuities, right? As for the rate, we need to use Excel's built-in function, right? And here's the something that you can look up on the internet, formulas. But these formulas are, the future value of an annuity is relatively easy to understand. It's similar, right? What they use, they used, I instead of R. But again, I prefer R because that's the real interest rate. I is nominal interest rate. Of course, it doesn't really matter because compounding or discounting, what we use is a nominal interest rate. But the reason I use R also is because it means rate, periodic rate, right? And then present value of annuities. This looks quite complicated, but if you rearrange it, it's exactly, think about it. This will be 1 over I, right? 1 over I, and this will be 1 over I times 1 plus I raised to n, multiplied by payment over I times, so it's original, my original formula. And then if you use it this way, if you do it this way, it gets more complicated. Okay, payment of present value of annuities, payment future value of annuities, n. How to find n in the present value of annuities, future value of annuities. But again, this is all, it's more complicated, right? I mean, the variant of the formula is just unnatural, right? To complex. So this is clearly better, right? And there's a reason why I use this version, because it gives you clearly the idea. It explains why there's an inverse relationship and direct relationship between inverse relationship between present value and R, and direct relationship between the present value and N. Okay. So next, amortization. Now, amortization is, in other words, is paying down debt in installments so that the principal will decrease in a decaying pattern, resulting in payment splitting into principal paid, in increasing interest in decreasing proportions, paid in increasing. Okay, I'm reading it like. So that the principal will decrease in a decaying pattern, resulting in payment splitting into principal paid in decreasing pattern and interest paid in decreasing pattern each time. So in other words, take a look at this. I've been telling you this monthly payment is comprised of principal and interest. So there will be 60 payments of there will be 60 payments, and you might think, every payment, the composition of interest and principal composition is constant. No, it's not constant. It changes. Early on it's mostly interest, right, and small principal, and as time goes on, interest gets smaller and smaller and smaller, and principal gets bigger and bigger and bigger. So basically, it looks like this. First of all, this picture is showing you how. Look at the height of the bar. The height of the bar is the constant. Height of the bar is constant, right? The height of the bar is constant. So that means the same monthly payment, monthly $6.99. So it's constant. But then the composition or the mix, the composition of the principal and interest are so different. So you see the green bar is the principal, green bar. Yellow is the interest. Early on, it's mostly interest. And then as time goes by, interest gets smaller and smaller and smaller. Principal payment, right, gets bigger and bigger and bigger. Okay, so this is how it is structured. And then, what is that red curve? The red curve represents the level of principal. The principal declines as time goes on. Principal balance, right? As the principal payment increases, principal balance will decline. And you have to also understand that the if this is the height of the bar is $6.99, obviously this point on the red curve, that's not $6.99 because that's the principal, and the principal as of time zero, it looks like 99,315 after the first payment. In other words, this height of the red curve is like 100,000, right? This height is like 100,000. So then I just say, you might ask, Professor, didn't you just say that this yellow and green bar, the height of that is $6.99? Yes, I did. So what that means is they are on two different axes. Okay, they are on two different axes. In other words, this red curve, let's say it is on the left axis, and the left vertical axis, on the left vertical axis, this level is 100K. Now these, payment bar is on the right vertical axis, and the right vertical axis means, on the right vertical axis, this point is 700. So when the the magnitude of the numbers, magnitude of the amount are different, we use two different vertical axes, right? The left and the right. And on the left, each level is like, $10,000. On the right vertical axis, each level is like, $100. So we go by different. But, this is, showing you declining pattern. Of course, that's how the payment will decline. That's how the payment will decline. So here, I talked about, in the past, I made distinction between exploding explosive pattern or exploding, constant, where's my pen? Constant, linear, and then exploding is also called exponential. It can be the patterns that the pattern, exploding, and then decaying pattern. I talked about decaying. I talked about the difference in these patterns before. So I'm not gonna. I want to talk about that again, just to jostle your memory. But this is all the time we have, so we'll have to call it a day here. Any questions so far? Any questions? Any questions? All right. It looks like.
Well, no, Professor.
Okay. All righty. So that's it for today. I will see you guys this Wednesday. Okay.
See you Wednesday.
Have a great afternoon. Yeah.
Likewise.
I'll see you. All righty. Take care, everyone. All righty. I'll stop sharing. Stop recording.